Welcome everyone. My name is Andrea Tocchetti and I research explainability through human-in-the-loop approaches. So, as you may know, in recent times there has been a strong push towards developing AI technologies. Now, acknowledge that nowadays it's not really a problem anymore to achieve high-performing models. Now the research focus has been shifted towards understanding why and how this model behaves, depending on what they do, basically. So, the two main words that we are looking at right now are explainability and understandability, because in the end, we humans are the final end users that in the end need to understand and care about how this model works. So while on one side we do care about having a faithful representation of the behavior of the model, on the other hand we care about understanding the model. And while nowadays explainability can be easily achieved by using several algorithms that are already state-of-the-art, well, understanding the results of these algorithms, that's a whole another story. For example, if you were to look at the pictures here on the right, let's take, for example, the first one. Is the machine learning model looking at the ears of the dog? Is it looking at the fur? Is it looking at the color? How can we get it, right? And I believe that the best way to achieve a human understandable explanation is to build them using human knowledge. This is why our solution involves crowdsourcing, human-in-the-loop approaches, and since sometimes users may not be really skilled with this kind of tasks, also some level of education. For example, crowdsourcing would help us in improving scalability and reducing the costs, and human-in-the-loop approaches instead will make our explainability very understandable. Sorry, I skipped one. So this is what we call the XP crowd, which is our concept for a platform in which we have three main actors. We have companies, we have knowledgeable users, and in the end we have standard users. Well, companies will just benefit from these to get basically an explanation for their models. Knowledgeable users will share their knowledge within the platform, and whose knowledge will be used to then train users to provide their knowledge to generate explanation for the models provided by the companies. Well, in the end, this is crowdsourcing, so users will be remunerated, and knowledgeable users instead will get data and will also get some exposure both for their knowledge and their research within the community that we aim to create. Indeed, the main advantages of our solution are the fact that, first of all, the final outcome would be human understandable, since it's built by humans for humans. We aim to lower the cost, and we believe crowdsourcing is a great way of doing that, and we aim to reducing the cost by 10–20%, and we also aim to build a strong community, which in the end will be able to improve by itself. Regarding the market, well, the market nowadays, of course, the AI market is way bigger than the explainability market. The AI market was estimated at 94 billion last year, and it's supposed to grow at a growth rate of 28.1% a year, while the explainability market is kind of smaller. Right now, last year it was 4.4 billion. This year is estimated to be around 5.5, but I believe that it will keep growing as this problem becomes more diffuse, let's say. With our solution, first of all, we aim to target image classification markets. And for example, right now we already have a basic solution implemented, but we also aim to expand to natural language processing problems. In particular, we aim at concluding the development of our approaches by 2025, and then start the development of the platform either after or during this period of time. In the end, we aim to achieve final release around the last quarter of 2026 and to complete the user engagement by the end of 2028 to achieve a fully running platform by the end of that year. The team is currently made by myself, Professor Brambilla, that basically leads the team, and also two master students that are contributing to our project. We also aim to involve more experts, mainly in the human-computer interaction, and also, of course, developers for our platform to achieve our final results. And let me tell you one last thing. Well, in computer science, we have this very sweet concept of silver bullet, which is a solution that solves every problem. Well, I believe that this time we are the silver bullets. Thank you so much.
I have a quick question about quality of the explainability power of humans, in the sense that humans can disagree on their interpretation, on their explanation. So how do you manage the need of defining a sort of inter-agreement level that is sufficient to say, okay, this is a good explanation?
So regarding quality assessment, I believe that in the end, the solution is scalability, which means that if in the end, so it's kind of hard to achieve, let's say, an even split, okay? We know, I mean, statistically it can happen, but it's kind of hard. And in the end, I believe that if we are able to collect enough data, we can solve these kind of problems. You know, I mean, either we get some explanations that are exchangeable in a sense that maybe they are similar, they're very, very similar. For example, I mean, for example, in the example that I made, the 4 of the ears and the ears, well, that's kind of a, let's say, borderline example, but in the end, we may get ear and maybe another similar concept, we can be still interchanged. So in the end, it's more than an exact explanation, it's more of a general explanation of how the model behaves. Also because in the end, in this part of my research, we mainly care about making something that's human understandable rather than something that is exactly. It doesn't mean that we don't really care about precision, about achieving an exact explanation. It does only mean that in the end, I believe that having something that's understandable but not really exactly precise is better than having something extremely precise but that you cannot understand, of course, because it gives you no value.
Your approach is very broad. I mean, explainability of AI is a big issue. So my question is, where is the first area you want to focus on? Because the amount of money you put on your table is not enough to cover everything. So what is the area you want to focus first? And secondly, how you are going to choose it? Because you can apply, if your software works fine, you can apply everywhere. So which is the first area, and now you are going to choose it?
Okay, so the first, I mean, mainly because of what we are working on right now, the first area we will be working on is mainly image classification and in general image recognition tasks. The pictures that I showed you in the first slide are actually some sample pictures from a project that we are working on right now. And this is just the representation part, which means that these have been generated using a well-known algorithm. And now we are working for the validation part, which is the main part involving the humans. In this case, we're just supposed to give you sort of an idea of what explainability is and how it can be achieved by using standard algorithm. So I'd say that regarding our first target, of course, it will be this field. Right now, our approach is model agnostic, which means that it can be applied regardless of the model. So basically, any type of image classification, image recognition model would work with our approach. I mean, we just have to adjust the interaction part between the model and our approach, but it will, of course, work. And I mean, regarding the money, I haven't really thought thoroughly about how much money we would need for every single step. So maybe it's just, maybe as you said, it's just underrated regarding the amount. But yeah, mainly I think that this should answer your question.